All right, guys, let's do number 54. Let's get started. All right, a person standing on the top of a hemisphere rock of radius r kicks the ball initially at rest at the top of the rock to give it a horizontal velocity as shown in the figure. What must the initial speed if the ball is never to hit the rock after it's kicked? I encourage you guys to pause this video to give this problem a shot. This is a very interesting problem because we're talking about a guy standing on his hemisphere. So this motion is already going to get modeled. So I'm going to draw this. Let me see if I can. There we go. So this guy is going to kick the ball. All right. So here's the hemisphere. What is the initial speed v naught that this guy has to kick in order to travel and not hit this rock? Because remember, if you travel it low, it's just going to hit the rock. Now, if you travel high enough, maybe it's gonna, bypass the rock, or maybe it's not. So let's kind of set up the motion so we can kind of get this out of the way. So this motion maybe looks something like this, and this is going to be the radius, and this is going to be x, because we're going to be solving for the other one. So in order for this to work, this g would have to be equal to v squared over the r. Notice that this is going to be the centripetal acceleration of the motion initially. Maybe not necessarily through the whole planet, but initially that's the initial, if you kick it at that speed. Because remember, this is just going to go straight down. It's not going to point towards the center once you kick it. So, but initially, if you kick it from right at that speed, that's definitely going to bypass the hemisphere. It might even bypass it like right at that initial minimum value. So that is the answer to part A. It's a very intuitive problem, believe it or not. So let's find that speed. The speed is really just going to be gr. So the answer to part A is v is really just going to be the square root of g times the radius. All right, so let's answer for part B. Okay, so that's the initial speed. With this initial speed, how far from the base of the rock does the ball hit the ground? So I think it's asking for x. So x is the way even though I drew it a little. X is going to be this whole distance, the whole thing that it travels. So I'm going to let y be 0. I'm going to solve for t. So when y equals 0, t is just going to be r, or 2 times the radius divided by g, square root. So x here would be, the speed is going to be the v naught times the square root of 2r over g. That would be the result. Now, keep in mind, this whole thing is x. It's asking for the whole base of the rock. So I'm going to say that this is going to be 2 times, no, that's right. So I'm going to say that this is going to be the answer, that this is going to be v naught over 2 radius over g minus the radius. I think that's the answer. I'm not entirely sure though, but I can quickly verify this. Anyways, folks, I hope you enjoy. Alright guys, I just checked the answer in the back. I'm pretty sure this is correct. However, they do simplify this, so let's kind of do that. Alright guys, I checked in the answer in the back. They do simplify this, so let's do that. So let's so we already got everything set up. We know that this is going to be the result. But what I'm going to do is I'm going to kind of simplify this to say that this is going to be the square root of gr times times 2 times the radius over g. That would be the whole thing inside minus r. And what I'm doing is I'm substituting v naught for that equation. So once you do that, the gr, notice that the g's cancel. You'd be left with r squared on top. That's going to be factored. So this would be left with r root 2 minus r, or in this case, r times root 2 minus 1. That is the solution. So either answer should be correct. Anyways, I hope this helps. Anyways, folks, I hope you enjoy.